Hello everyone, my name is Leo. I'm a data consultant in Keboola. Today I'll be presenting you guys a presentation on how to create a component in Keboola. So after this presentation, hopefully you guys will learn a lot about Keboola and how to create a component with Docker. So before you start, there are a list of things that you need to know before you start to create a component in Keboola. First, you need to know how to code in general, any language, as long as you know how a coding language works, that will be nice. Second, Docker introduction. Even though we're going to provide a Docker introduction in this presentation, it is still ideal for you to find out what Docker is. Third, Keboola introduction. I assume by now you guys are probably invited into a Keboola project, and I hope you guys have browsed through the platform. In this presentation, I'll also give a general idea on how Keboola works for components. Git introduction. To be able to create a component, a user are required to know how to use Git. First is to use the version control. Second of all is when everyone or a few of you are going to develop a component and you guys are going to work on the same component with different features, it'll be ideal if you guys know how to know Git, because that will be important. The third of all is going to be API introduction. A lot of components require API access. If you guys don't know what it means, please click on one of these links or click on this link to find out what API is. Number 6, basic knowledge of JSON. It is really crucial for you guys to know what JSON is, because a lot of backend in Keboola, we use JSON. All right, introduction. I'll first talk about, in general, what Python or what coding language we use, how Keboola works as a package. So our preferred programming language for creating component is Python. One of the reasons why is because it is the most commonly used language across our platform. And then we do have shared guidelines and knowledge base, meaning that we will be able to provide you a better support. Following are the basic steps in creating a component. First of all, you and your team or your seniors, they will have like a requirement scope gathering. That might include like API documents, what sort of restrictions you guys are gonna have, authentications on how to access to the source, all right? And the second step, if I'm you guys, I will first test out the connections if the component require access to API to make sure that everything on your backend works. So example of application that you guys can use is Postman or Paul. Third of all, you guys will need to have a code design. Okay, so you guys should lay out the logic and libraries required to execute the requirements. Fourth, heads down and start coding. Number 5 is unit testing. Testing out all the functions that you guys have in the components. And second of all, you guys will need to make sure that the errors are fully controlled. If you guys have a meaningful error message, it will be better for the users to identify what's wrong in their configurations. And after everything is done, you guys will need to do like a documentations. So basic information on how users can configure or run the component, okay? And also a list of constraints, including like API limit or component limit or component memory limit, okay? Those needs to be documented in there. So general rule of thumb for creating components. First, do not repeat functions of existing components, meaning that let's say if you have files you want to extract from Google Drive, you should not create a function in your component for that. The reason why is because we do have a Google Drive extractor in our component directory. Second, Every component should only do one thing, meaning that one component for extractor, one component for enrichment. You don't combine those two together. Main reason is because if there are any issues with one of the component, it'll be easier for the developer to go in there and debug. So if you congest like a lot of functionalities in one component, it will take longer for the developer to debug. Third, do as limited data processing as possible. Technically, a component should supposed to do extraction and or enrichment. They're not supposed to process the data, meaning like filtering, output table, and stuff like that. Number 4, avoid optional data modification. If a data file is in different encoding format, okay, user has the option to use a processor, which is one of our type of component, to load incompatible data sets. So in the later slides, I'll explain to you guys what a processor is. Number 5, avoid iterations. Example will be, so downloading on multiple files from one system, okay? Instead of looping the whole folder to get all the files, users can just use configuration rules to implement the processing of only a single table. Details, it will be in the later on slides. In Keboola, there are 4 types of components. The first, application. Second, extractor. Third, processor. And the fourth one is the writer. So what does application does? So an application is used to enrich the data or adding values in new ways. Okay. So it processes any input data from Keboola storage as a CSV and output the result as a CSV. One of the example will be NLP analysis application. NLP stands for natural language processing. So what does this app do is it's basically taking a list of reviews or any words, and it will analyze the text and provide the sentiment values for the user. Second is extractor. What it does is process input tables from external source. So meaning that there should not be any input tables from Keboola. So all the tables should be coming from elsewhere. Let's say a database or REST API. Another example will be Google Sheets. Third, processor. So processor is used to adjust the inputs or outputs of the components. So meaning that these tables already exist in Keboola. Okay. One of the example is breaking up Excel SX files into CSV files, or if you have like a input zip file, we also have a processor that can convert that zip file into CSV or decompress it for you. Fourth, writer. So what it does is pushing data into a new system. So if you have tables from KBC, you'll be exporting that table into somewhere not KBC. Example would be Snowflake database, MySQL, or Go database, stuff like that, or even BI tools like Tableau. All right, so Docker. What is Docker? Docker is essentially a technology stack for running things in the virtualized environment. It is stateless, meaning that there will be no credentials or metadata stored in the container. So Docker images, what is that? So Docker images is essentially your component code. So it contains command, what it needs to run an application. Containers is a virtual sandbox environment created to run the specific version of the Docker image. Okay, so a container will contain the Docker image. If you guys want to find out more about Docker, below we have 4 links where you can learn more about Docker. Okay, Docker introduction. So the first Docker file over here is essentially it will be compiled with your component code. What it does, it will build your component and convert that into a Docker image. Okay. After Docker image, it will be stored in, let's say, Docker Hub or ECR or somewhere you prefer. With the Docker image, then you will need to spin it off with a Docker container, meaning that it will be a isolated environment to run the Docker image. Okay, one more thing to point out is that since it's stateless, the credentials will not be stored in Docker image unless you physically put it in your component code, which is not a best practice, and please do not do that. So this is the Keboola ecosystem. On your left, you will see Keboola. Let's imagine this as our platform. This isolated container, imagine this as a Docker container. So how it works is in Keboola, we have a storage API called Docker Runner. So what it does, it will create a container, this container, okay, a Docker container. With that, it will pull up the Docker image with the component code that you want to run. After that, it will execute the code, okay. After the code is executed, there will be outputs, okay. Then with this container, it will put with your component configurations, it will put it back into the desired storage. Okay, so if you look at this, I can tell you that the outputs are not stored in Docker. Even the credentials, if you have credentials, this is where it will send it into Docker. Okay, after this Docker image has finished what it does, it will be killed off. Okay, so any metadata stored within this thing, it will be gone. Okay, this is a simple version. This is the detailed version. Okay, so here, well, basically this whole thing is Keboola. Okay, so we have Docker runner over here, all right, and storage API. Component definition means that the image details. So what it does, it will pull the Docker image. Okay, it will create an isolated container. All right, so it in this container, the storage API will export whatever input mapping, input tables or input files into our input folders. With the configurations, it will run the code. After it's run, it will export a list of tables back into Keboola. So with these languages like state file configuration, I would go deeper with you guys in a bit. So component interface. So in general, this is how it looks like in Keboola platform. Okay, so applications. As mentioned, we have 4 types of components. There are applications, extractor, writer. So in this case, this is applications. Okay, the application is name, data health. This is one of the configuration we name it test. Okay, so here, this is the table input mapping, meaning that this component would need this tables to run whatever its purpose is. Okay, configuration. These are a list of configuration descriptions for the users to know. Let's say if you have primary keys or how to find the primary keys in your platform or the component, this is where a user is supposed, or the developer is supposed to enter the configuration descriptions. Component configuration settings. So let's say if a component is going to request an API, usually they require a username or a password or API keys. This is where the user will be able to enter them. Component runs. So these are details about every run that the component performed. So let's say in this case, red means fail, green means good, yellow means it's still processing. In this case, in the last run, we had like a failure in here. Okay. Component configuration versions. this act like as a Git version control. So let's say if someone changed the API key or like the settings in here, the user can always roll it back into like the previous configuration in case something is screwed up. Okay, so if you click into one of these runs over here, we call them jobs, it will lead you into this page. Okay, so in here, this job is a job status. Okay, so as I mentioned, green means success, red means failed, and yellow means it's pending. In this box, these are the stats of the jobs. So let's say like when does it start, when was it created, and when it ended, and who created. Okay, and the duration of the whole component run. In the mapping tab, this is where you find out if the component imported any tables from KBC or exported any tables into KBC. Correction, I named it wrong. So it's basically input table means that these are the tables that the component uses to run. Output means that these are the tables that the component outputted. Component log messages. So this contains a list of functions or logs that the component needed to execute. So it started from storage is a Keboola job that import tables into this component to outputting mapping done. So it did something with a mapping and then output the table here. Okay, so interface between KBC and the component. So to start, we'll start from configuration. The developer has the option to specify how the component's UI will look. Okay, so with the UI configured, basically the developer has the flexibility to present the UI a more friendly user way, so whoever is going to use it is easier. So in this case, let's say we're going to connect to Asana API key, pretty straightforward. So the next slide is the configuration in raw form. So if I present this in to a business user, they probably don't know what is going on. Okay, if you put it in a nice way like this, it's easier to tell them that, hey, put in the API key. File input and output mapping. Okay, so whoever is using it will need to find out what files the component will need to run, and usually they're described in the component configurations. Okay, there are two types of input mappings. One is called table input mapping and file input mapping. So files in general, they're not in CSV, or they can be CSV. It's just that like there are more options to import other type of files like HTML file or picture files. Table input output mapping. So table, they has to be CSV formatted tables, like here. Logging. So as mentioned, so the user will be able to tell the stage where the component is at. And then with informative component logging messages, user will be able to track or debug how the component behaves throughout the whole component execution. So when you write a component, it's really crucial to have a informative logging messages. So if you look at the log over here, you can clearly see that when the component was running, it imported this table, okay? And after that, it does something with it, and then it outputs. Next chapter, we're going to talk about hands-on developer portal. You guys probably have no idea what developer portal is. Okay, developer portal is where we manage the list of components the user created. Let's say if you create it, then you will have this interface to manage the components. So it contains information on public components that are available in our KBC platform. prior development, everyone should have access to developer portal. That's the first. Second, you guys will need to have access to US or Europe KBC projects. Third, GitHub account, Bitbucket account, or GitLab account. You will need one of them. As mentioned, you will need to create an account in developer portal. Okay, this contains a link that leads you guys to developer portal. It will be required to create a new component. First of all, it's free. That's a good thing. And it uses different credentials than KBC. So after you reach the developer portal, this will be the create account interface. So where you input your name, email, password, and confirm password, and submit. After you're logged in, it is mandatory to join a vendor. So every component has to have a vendor assigned. If you're joining an existing vendor, the vendor admin will have to approve your requests. If you don't have a vendor, then you can just create one with your own name. Okay, then Keboola, the admin, will approve your request, and then you will receive a developer project in KBC. So create a new vendor or choose a vendor to join. After you've been approved and you start to create a new component, below will be the component type that you can create. Extractor, writer, application, and there's a missing one over here. It's called processor. So over here, the name, this will be the name of your component. Okay, the type of component, which is one of these: extractor, writer, application, or processor. Here, after you type in the name, it will automatically generate a ID for you, so you don't have to type this out. And over here, component ID, which is the same as this. This is your vendor ID. It will not be your user ID. And this will be the component ID name. Okay. And also one important note, do not use words extractor, writer, or application in your component name. After you successfully create a component, in this case, I named it demo testings. Okay. ID is KDS team dot extract, well, X dash demo dash testings. And here it will have descriptions on who created the component. Now let's get into this component itself. We click on edit. Edit. All right, once we're in here, this will be the page that you will be able to look at. Okay, as mentioned, this is the user created ID, name, type, short description, and user has the will be able to upload the desired icon for your component. So the user, as simple as clicking change the icon, then upload the image. Okay, and then let's say if user they click the wrong component type, then they will be able to change it from here. So extractor, change it to application and stuff like that. All right, so the next section will be this repository. Okay, this is one piece of really important piece of information for KBC to run the component. Okay, the reason is this is the description of where and what tag number of your Docker image is. Okay, so after the developers have created Docker image, they will need to upload into one of these, should I say provider or a Docker runner. Okay, EZR, Docker Hub, Quay, Keboola Builder. Okay, in general, this is how a Docker image looks like. Okay, with the Docker account username. Okay, Docker account username, not ID, not your username in KBC. This is a user ID from your, let's say, Docker Hub account, EZR account. Okay, Docker image name is basically what you name the Docker image. Okay, this will be the name. Tag version. So let's say if you have multiple version of the Docker image, this is where you specify which version to run. Okay, so in this example right here, let's say we go to the source ECR. Image name is called Keboola. Okay, so our username for this Docker image is Keboola. Okay, MySQL-extractor is essentially the Docker image name. Tag example will be version 1.5.3 in this case. Below here, user will have to put in the license of the component, documentations, as well as the source code. Default bucket. So if enable, users will not or do not need to define the destinations of the output tables. So it's highly recommended to have it enabled. So it saves you some trouble from configuring the output mapping. So there are two default bucket stages. One is called in, one is called out. In general, tables are raw outputs from the source. Those are categorized as in. So example will be a lot of extractors. They should be in. So for out, tables that do not require further transformations or enrichment. Example will be data enrichment applications. So those will be categorized as out. So meaning that you're not going to process it, it's going to output somewhere else, then you put them in out. UI options. So this is where we can specify what the component will have on the component interface. Okay, here I put generic Docker UI and also generic Docker UI table input. So if these are not specified, then the input mapping will not be showing up on the component interface. Details of the UI options I'll be telling you guys in the deep dive. Configuration schema essentially is your UI. So the back end of it is configured by JSON. Okay, so with a poor UI, just JSON, it will look like this. But if you have it configured and put it in here, it can look as nice as this. Details will be broken down in deep dive as well. All right, logger. So in KBC, there are two types of logger. One is standard and one is Guelph. So standard, basically you don't need additional work for it. All you need to do is just output, let's say print or std out, then that's where the standard logger is. So Guelph, it requires some implementations, but it offers much greater flexibility. So the logger message will look way more neat than the standard ones. And so when it's more neat, it's easier for user to tell what went wrong. And there will be more details in deep dive. Required memory and process timeout. So when a user create a new component, there's always a default value configured in here. So if the user is bouncing on the memory or a runtime limit, they are required to request a support ticket with reasons, of course. So if it's not a valid reason, then unfortunately the support will not grant you the required memory that you want. Our next chapter we're going to talk about is we're going to dig deeper into how Keboola interacts with Docker. So as you guys have seen before, this is how Docker Runner works and Keboola Storage API. So first, what it does is it download and build the Docker image with the Docker Runner over here. So it built, and then it will build a container. Second, it will download all tables and files labeled in the storage input mapping from storage. So from here, This is the input mapping. So we have tables or files. Okay, they're defined in storage input. Okay, then it will be pulled from storage API into the Docker Runner container. Create configuration file. That's the third step. So with the UI configuration, it will create a list of parameters, state, storage input, and storage output to define how the component should be run. Fourth, it will run before processors if configured. So remember when I mentioned about there are 4 types of components, processors, they can neither be executed before the component run or after the component run. Okay, example will be, let's say if your component is gonna download some zip files, then it will be a good time to use a decompress processor to decompress those files automatically for you instead of doing it in your application. Number 5, Docker Runner is going to spin up a Docker container and execute the Docker image with the parameters, the input files or tables and configuration stuff. After it's being executed, it will be uploading all tables and files labeled in output mapping. Okay, so here storage output is basically the job configuration. That's where we're going to define the outputs from the container where it is going to be stored in our storage API. So here is going to be defined. If you look at this, follow this line over here. Okay, this component will execute, will be exporting this table with this definition, and it will be put it back into Keboola storage output tables or buckets. After the upload, it will delete the Docker container and all temporary files generated from component. So let's say if there are any credentials that are inputted into the Docker runner, then this will go with the Docker runner. Okay, so the credentials won't be stored anywhere. It will not push it back into storage API unless they state it in state file. Then it will be pushed back in there. Component responsibilities. So if we look back into this graph, we have 2 things over here. There is a Docker runner and the code itself in this container. Okay, so the image and the container. So the component, which means the code, so it is only supposed to read and reconfiguration and input tables. Second thing it should do is writing the results into designated folders or files. Third, it should properly handle the success error results by setting appropriate exit methods and messages. So messages could be logging messages, appropriate exit methods. We're talking about like error controls. So if some sort of error pops up, so how should you handle it? Should you execute the component or should it keep going? That's what I mean by proper handle. Docker Runner. So what Docker Runner is supposed to handle is the authentication, ensuring the component is running by authorized user tokens. So second thing is booting up and terminating Docker container to ensure the component run is in a predefined environment, but not running in like a random environment. So it also needs to ensure the reading and writing into KBC storage. Component will only have access and rights to the file table specified in the input mapping or the output mapping. So if you don't specify the output mapping or input mapping in the component, the Docker runner will not be able to write into a different bucket if it's not defined. So component isolation. Each component is isolated from its own Docker container, meaning that unless you call the image, there's no way the containers can talk between, there's no way there's going to be any conversation between containers. KBC component environment. So every time when Docker Runner spins up a virtual environment, this is how it looks like in general. So there's this is basically the component. data file. Okay. In here, there's configuration. In it are lists of input mappings, input files or tables. Okay. Out means output mapping. So what is configuration file? So in short, it is a config.json. So these are user custom parameters which they wish to pass it into the component. Example would be like API keys, endpoints, stuff like that. Input mapping in folder is data that your component will need to run. Output mappings are essentially the files that the component will output. Now we're going to go deeper into configuration file and what it is. So inside configuration file with parameters, these are user-defined objects passing to the Dockerized application. Second, storage, the configuration of input mapping and output mapping essentially are these ones. So runtime, runtime configuration for Docker images. Normal users cannot alter these parameters. If the user needs to increase the runtime limit, they will have to submit a support ticket specifying the reason for the increase. Processors. There's also an option to specify what kind of processors the user wish to run before or after the application run. Okay, authorization. KBC can handle OAuth authorization. Okay, OAuth authorization is stored in KBC and it will be injected into the configuration for each run. So to emphasize this, the OAuth authorization is not stored in the component configuration, but it is injected into the configuration every time when it spins. Number 6, image parameters. Example will be state file. So it's basically object passed from the component. Number 7, action. So it provides a way to execute very quick tasks in single component. So specifications are not stored in the component configuration as well. Now we're going to go over parameters. So they are JSON formatted. Essentially, we're just talking about the UI over here. It contains channel for components and KBC to exchange data. So whatever you put in this UI, this is the raw form of this UI essentially. Okay, so the component will need these to run, right? So configuration file will be the source or the link to exchange the data, well, to pass the data into the Docker container to execute. So allow the user to input specific parameters required for the component run, as I mentioned. So the user has the flexibility to create an UI for the component. So in this link, it will lead you into like a JSON schema designer. So that is where you can try to put in a JSON that can format it into a UI like this. Encryption. So image parameters and stack parameters are both supported. So best practice, always store encrypted values in stack parameters. The reason why is ciphers are not transferable across regions. How can we do that? Is by putting a # in front of the JSON property. So let's say if the API key over here, let's say the password is 1234. After you put a # and click save, it will be encrypted into a code that no one can really read it. Okay. On UI level, on the raw JSON level, it will look like this. But on the UI level, it will look like this, like a password. Next thing we're going to go over is input mapping. Okay, so before we have this present in the component UI level, these stuff generic Docker UI table input or file input has to be inputted, enabled, or enabled in the developer portal. Inside your developer portal, there's a section called UI option. If you want it to be present, let's say table input, you will not need to physically put in there. If this is not here, this will not be here. Output mapping configuration is very similar to input mapping. If you want it to be enabled, there is an option called generic Docker UI table output. If you want it to have an output mapping, that's need to be enabled as well. As mentioned before, is ideal to enable default bucket. What it does is any tables inside this folder, that folder structure, data out tables, it will be outputted into a assigned bucket for that component. By the way, this it refers to the bucket definition, but not the input and output mapping definition in the component. Again, this defines the bucket definition, but not the input or mapping in input or output mapping. Processors. Okay, with processor enabled, this is how it will look like in a component. So here, extractor, we're using it as a test. Table input mapping, we have this in here. Configuration is all configured. And then if the generic Docker UI processors are enabled, they will be all the way to the bottom of every single component. Okay, so there's before and after, meaning that before means that before the component executed, after the processor that's put in here, let's say, what should we do? So yeah, let's say it does something, and then after it's executed in series, it will run the configuration, and after that, it will execute the processors that are specified in after. A list of available processors can be found in this link over here. Next thing, manifest. So it contains or provides additional files, tables, information during file import or file exports. Where do they locate? They locate in the data in table or file, or data out table or file. So they are in these files. In the data in, it contains additional information about tables and files in the input mapping. Out, vice versa, means that it contains details of the output file. Manifest file formats are in JSON only. Okay, and how they are presented is, let's say if I have a file.csv, there will be another file called myfile.csv.manifest in the same folder. So this is how it looks like. Okay, so let's say the file name is inc docker demo data.csv. If we have a manifest file for this table, it will be under the same name plus dot manifest. It will contain the metadata about the files, tables, and input mapping. And this is an example. All right, inside the manifest, this is how it looks like. Okay, with ID, that will be the input table storage location. We have the name object over here. So it refers to the table name of the component configuration. And there's also metadata, column metadata. Back to this page, after metadata and data column metadata, there's also when the last table was when this table was last changed, when it was created, when it was imported, columns. These are the list of columns available in this table. Primary key, what's the primary key of this table in Keboola? They can all be found in this manifest file. Manifest for output table mapping. So what it does is specifies the metadata of the data being pushed into storage. It is optional unless it's specified by the component or is needed. Let's say a slice file, which I'll go deeper in later on. So it override the end user configurations. If it's not specified, storage would define a manifest for you. So there will be no primary keys, and it will be in the default output mapping unless it's specified in output mapping. Sorry, again. So it will be outputted into default output bucket, not mapping, unless it's specified in the output mapping. How it will look like in the output structure is going to be in tables, output.csv. If there's going to be a manifest, that's going to be under the same folder, under the same name, plus .manifest. This is how it looks like in the output table manifest. Okay, there's destination. With this destination specified, it will override the table name generated from the file name. It will specify where the end user wants to output the table. If this is not specified, it will output according to default bucket or the destination user defined in the output mapping. Columns. So it defines the columns of the imported table. If it's provided, the CSV is assumed to be headless, meaning that there should not be header in the CSV file if it's specified in the columns. Slice tables are required to configure columns option. Explanation will be later. Incremental, there's an option to do incremental load. If it's specified without a primary key, the output table will append into the storage. All right, so we just talked about input-output table mapping for manifest for input-output table. Now we're going to talk about the manifest for input file mapping and output file mapping. So here's input file mapping. The manifest will be stored in the data folder in files. So it will store the metadata of the downloaded file. If it's an image, then it will be named here. And then if the user wish it to be public, then they will it will be specified in the manifest over here. If there are any tags, it will be listed in here. Their size, there's max H days. Okay, this is the output file mapping. It will be stored in here, data out file. The manifest configuration is completely optional. So the user have the option to specify if it's public over here, if it's permanent, if it's encrypted, okay, notified, or any tags. So if permanent, if it's disabled, the file will be automatically deleted from storage after 180 days. Notify, if it's enabled, the members of the projects will be notified for a file output. So if it's public, anyone outside the project will not be, if it's not public, I mean, anyone outside the project will not be able to access to it. This is one of the use case for manifest. To the left, you can see the configuration we have for an application that's called Event Snapshotting Tool. So the purpose for this app is to capture any change, if there are any changes to a table. So in our table over here, we have the wines as a table input mapping. And there, as you can see, there is no output mapping over here. So under normal circumstances, we'll expect the outputs from the data out from this guy over here. So it will be output into a default bucket. Okay, but the author of this application, he has a really specific use case that he wants to store in a specific bucket. Okay, with a manifest set up over here, okay, the application will now write into a specific bucket incrementally over here. Okay, so the user can also specify the primary keys. So without the primary keys set up, as mentioned before, whatever you have in the output, it will just append in the table. Okay, one more thing to point out though, if you're writing into a table existing in the storage, the user will need to ensure the importing table's metadata will match with the metadata of the table in the storage.
meaning that any incremental settings, primary key settings have to be aligned. Okay, the output table can contain more columns, but not less. If you have less columns, it will fail.
So earlier we talked about slice tables. Now we're gonna give you more details about it. Uh, slice table, sorry, is essentially put tables in a subfolder with the same name. KBC then will merge that tables for you, meaning that users do not need to manually merge slice tables in the component. Okay. First requirement is that the manifest file is required. Slice files cannot have header rows. Columns need to be configured in manifest file or output mapping configurations. So this is how it looks like. Date, data, out, table. This is the file name folder. Okay. And this is part one of this file. You store it under the folder name. Okay. And that will be a manifest for this file. Okay. If you output this into Keboola, Keboola will automatically merge part one, part two for you and name it under myfile.csv. Okay, and then manifest will need to define what kind of columns this file is supposed to have. So slice tables, manifest configuration, option, destination, columns. Columns is required. Next thing we're going to talk about is called state file. It is used to store the component state for the next component run. It can be found for input, data in state.json. It will load from a configuration state storage. After it's done, let's say you want to put it back for the next run, you store it in data out state.json. The properties of the JSON state file is a JSON file only. Okay. Any empty state file or no state file output will remove the state value. It is safe only when the application is getting executed. The file cannot exceed 1 megabytes. The state file is not intended to store large amount of data. Next point will be to modify state file. User will have to access the data through component configuration API. With simultaneous runs in the same configuration instance, the one writing the save file the latest, it will be saved. So the earlier run, it will not be saved.
What we have over here is one of the extractor we have that's called review trackers. The purpose of this is to download reviews from a list of sources. Okay, we want to run this extractor on a daily basis, but this API does not support parameters like start date or end date. So, but it supports the query parameters like which page number that you want to start download and stuff like that, or the last page that you want to fetch. Okay, so what we did over here, so we store the last page of the extractor fetch the last time it ran into the state file over here. Okay, so this way we can avoid the extractor to request the API for like a full data set every single time. Okay, so this is the state file over here, and what you can see over here is the what's contained inside the state file. Okay, so let's say if I'm running the extractor right now, if there are no more additional pages to request, let's say for endpoint reviews, okay, the last time it ran, it fetched up to 31 pages, okay, and then so this time if we run it, if there are no more additional pages that we want to request, then we can store this state file into the out folder. This way, next time when the component runs, this state file will be passed on to the next run's input mapping. It will know which page to start fetching.
Okay, OAuth. In Keboola, we have an API called OAuth Broker API. What it does is it create and manage for API resources
utilizing OAuth 1 and 2. What it does is review and decrypt for a target component project. If user copy an encrypted password from a component or project, the password will not work in another project. Which means that user will not need to create a process in their component to gain authorization to the source, but it must be enabled by support. In the component interface, it will look like this. Authorization, after you click on authorize account, it will lead you to a login site where you input your credentials. So how does OAuth credentials inject into the component? It will be inside the component configuration file. There will be a property called authorization with what you need it. So there is credentials, app key, app secret. This could be the API key. They will all be in here. Environment specification. So components use several channels to exchange information with Keboola. It is mainly structured folders and configuration files. Every component has full access to the outside world. So with network type enabled called bridge in developer portal, then every component has access. Environment variables. The first one I'm going to talk about is KBC data directory. It is always the data in KBC. So every time when a Docker runner spins an environment, it will inject this environment variable during component development or component run. KBC run ID is the run ID from storage, the ID for every run, essentially. KBC, the third one will be KBC project ID. This is the ID of the project in KBC. Fourth one is KBC stack ID. Okay, the ID of the stack, basically the Keboola's region. Number 5 is KBC config ID. The ID of the component configuration or hash of configuration data if the configuration is not named. Number 6, ID of the component is essentially the ID you see in the developer portal. And then there are also some variables that are available if the for token are enabled in component configuration, but it has to be approved by support beforehand. So there are 5 of them. The first one is KBC project name, which means the name of the project. The second, KBC token ID, which is the ID of the token running the container. The third one, KBC token description, essentially. The fourth one, KBC token, the token that is running the container. And the fifth one, KBC URL, storage API URL. As mentioned earlier, there are 2 types of logging in KBC. One is standard and one is called Guelph. Well, the full name is Greylock Guelph. The first one, standard output and standard error. The user, there are no extra work from the component, so all the user needs to do is to print out all information messages in this STD, well, basically standard output, or all error messages to standard error. So for Guelph, user would need to implement or include the Guelph logger in the component, and it needs to be enabled in the developer portal. And it offers a much greater flexibility, and it can send different kinds of structured message. There are error, information, warning, debug. So now back to the standard messages. So there's STD out and STD error. Docker Runner will force the component STD out content live into the storage API events. The logging level will be information. So for anything that's content from standard error is collected and added as the last event of the job if it exists. So the log level is going to be error. So these standard message will be displayed in the job detailed. And another good thing is the Docker runner always keep track of all the encrypted values. Encrypted values will always remain hidden if you find that in the component events output. Next thing, logging gilf. So as mentioned, it sends a structured event message. Developer has the option whether or not if they want to display them. There are a few level of visibility over here. One is none. Message is ignored entirely. Camouflage. Generic error message is shown to the end user instead of the real message content. Full message is logged internally. Normal. Even message is shown to the end user. Full message is logged internally. And the fourth one for both is full message is shown to the user, including gilf additional fields. Okay, so these are all the gilf default settings for message visibilities. So there are debug, info, notice, warning, error, critical, alert, and emergency. To enable gilf, the user will have to include these environment variables inside their code. So there's KBC logger address, the IP address of the gilf server, and also the port of the gilf server. Speaking of logging, there's also error handling. Depending on the component exit code, the component job is marked as successful or failure. So if the component is exited with a 0, which means the job is successful, okay, so the status is going to be green, success. B, there's exit code equals to 1, which means the job failed with user error. On the job status, it will show up as a red error. Same as C, exit code larger than 1, job failed with an application error. It will still show up as a red error status in job. So the rule of thumb of creating logging messages, try to avoid nonsense messages, okay? And then avoid errors users cannot solve. Like example would be like your OpenSSL library is outdated, please update it, that kind of messages. The third one will be provide guidance on what the user should do. So let's say if they are missing the start date parameter inside the UI, so outputting a meaningful logging messages like, let's say, please enter the start date parameter, then this will provide a guidance on what the user should do. So they don't always have to go back to the developer and ask them, how can we do this? How can we do that? Stuff like that. And avoid deteriorate leaking sensitive information. Any credentials or tokens should be filtered. So in the logging messages, you should not see the token itself. Is kind of a best practice. Memory. So every memory should be written so that it processes data in chunks of a limited size. So many of the KBC components run with less than 100 megabytes memory. Even though the KBC platform is capable of running jobs with 8 gigs of memory, but usually supports they're not really happy to allow it unless you have a really valid reason for it. If the user needs the memory capacity for whatever reasons, again, they will need to submit this request to support. Our next topic is publishing and deployment. In general, this is how we run the component. This is code. So I'm gonna give you some context about what's going on in this code. So there's volume. This is to ensure that we're gonna mount the data folder into the image. So this data folder, it contains the component configuration. There's output and input mapping as well, and the state file. Memory and net, so it's basically setting up the component limits. So it's ideal to limit the component memory with the memory developer portal restricted. So you will know that you will bounce on the memory when you're developing the component. E, it means that environment variables. Okay, so let's look at this code again. So there's Docker run. We're mounting the data folder in here. We're defining the memory usage. Bridge. E means environment. This is going to be run ID, project ID, and the data directory, config, and at the very end of this, the highlighted part is telling the Docker what Docker image to run. Okay, so let's break it down. Create.io is Docker source, right? So username is Keboola in this case. The image name is Keboola-test.xdocs-tutorial. Okay, at the very end of it, it defines the image versions. In this case, it's 0.0.1. Okay, users for deployment, users have the option to use ECR, Docker Hub, or there's a Keboola builder to store their Docker image. User will need to tag the image with a version number because that is how the developer portal will be used, using that version number to run the image. After you push the Docker image into, let's say in Docker Hub, in this case, there's a 0.1.0 here and 0.0.08. Sorry, no, 0.0.8 here. In this case, we're gonna put the details into the developer portal. So in this case this is my username, Chan Leo C. Okay, this is the component name. I mean the Docker image name. The source is Docker Hub, right? So here we configure the type as Docker Hub. Image name, again, my username, slash the component, the image name, and the tag. So let's say if we want to run 0.0.8, then you just change this tag into this tag. For deployment, if the user wishes to automate this process, the detailed instructions can be found in this link here. So why should we automate this process? Is because it saves users a lot of time from manually pushing the new image and building image into the Docker Hub or ECR. And it can trigger like the whole deployment process when a new version is tagged into the image. And then while is pushing the image, users can just relax and sit back for like a few minutes. There are ready-made tutorials for GitHub and Bitbucket. For Bitbucket, we're gonna go through that in our template. All right, so now that you have pushed the component, you have added the Docker tag number, and you're ready to go, and you want to test it in the project. But if the component is not public, then you will need to manually input the component into the project ID. In this case, let's say you're a US customer, okay? HTTPS connection.keboola.com, okay? It's the base URL for Keboola. There's admin, projects. After projects, there should be a project ID. So enter the project ID of your project that you wish to add this component, okay? If it's extractor, put an extractor. If it's application, put an application, okay? Here, there's vendor ID, okay? And there's component name. So if the component is not public, you will need to manually enter the vendor ID dot component name at the very back of the URL. Okay, once you enter it, then you will be able to add a configuration. When it comes to debugging in KBC, okay, is useful for obtaining a environment configuration for a component. Okay, what debug mode in KBC do is it create a snapshot of the data folder and it will upload the snapshots to the file section in storage. Okay, and then there's going to be another snapshot with results. Okay, it will be created after the component run and it will be stored in storage as well. Okay, however, you cannot just click it in the component UI. There is no debug button anywhere on this interface. User will have to enable it through API call. Okay, the API call is in this link below. run tag. What it does is allow a user, so let's say you're developing a new version of the component itself, you can run the job in the production development using a specified tag of the Docker image. Okay, back then we mentioned Docker images over here, right? So let's say in the production environment, let's say in developer portal, the current version is 0.0.8, right? And let's say if I'm developing 0.1.0 right now, if I want to run this version in the production environment, we can do that through run tag. Okay, so it can help developers to test unreleased image on a real configuration without affecting any other project's user using that component. So, but the bad thing about it is the user has to specify the job through API calls, meaning that this is only going to be a one-time call. Okay, unless the user push the new tag ID into the developer portal, it will always run the tag number that's specified in Docker Dev portal. Next topic is going to be the KDS Team Python component template. So KBC Team Basic Python template, it can be found in this link. So it's under KBC-Python-template. The reason why we have a template for this is because we do not want to reinvent the wheel. We want to have like a standardized code structure, and we want to reuse and expand our shared code base. So what it has in there is it contains the details on the mock KBC environment for testing purposes, and also have like a recommended code structure in there, and also teaches you how to, or help you how to set up deployment and automate it. And then there's also codes to aid users to deploy and test components. So inside the template, this is how it looks like. There's component config file, component long descriptions, short descriptions, config schema, configuration description. These four over here, it will be pushed directly into the developer portal, meaning that if you have the writing of the component descriptions in here and the configuration schema, it will automatically be updated into developer portal. So you don't have to go in there and physically change the descriptions every single time you make some changes. So data folder here, this is the mock, not mock, but sure is mock, the data environment that every time the Docker runner spins up. So in here, there contains the config file, there's input mapping, output mapping, state file, manifest files. Docs, it's just a place for you to put your documentations. And these are predefined scripts for build and run and testing the component itself. Okay, and then there's source. This is in fact a screenshot of a current existing component. So this folder in here contains libraries for the component to run. Okay, but other than that, component.py is the main component that will be main pieces that will be executed in the component. So tests is for you to put down your unit testings in here, test out your code thoroughly, error controls, everything should be tested in here. Bitbucket pipelines, with the template, we provided you a Bitbucket pipelines by default. Okay, so you don't have to redefine the pipelines itself in Bitbucket. So there are change logs. So this is where the user can put down the list of changes they apply into the code every single time when there's a new feature added in, or there's something that needs to be debugged. So this will be a good place to put down everything other than the commit messages. Okay, there's deploy script, and there's also Docker compose. This will help the user to run the component locally. Okay, Docker file is basically the description of how the Docker image is going to be defined, or how the image is going to be running the code in the Docker environment. Flategate is a styling. So as mentioned, that we want to have like a standardized code and structure and style. So Flategate will be a good tool for us to use to standardize the viewing of the code and the style of the code. So there's license is provided as well. README is basically a description of the component where this will be pushed into the Bitbucket itself. So every time when you click on the component in the Bitbucket, README is gonna show you like a list of configurations of the component and stuff like that. Requirements is basically containing a list of libraries that this component will be required to run. So let's say if the component requires pandas in general, then if the pandas is not installed in the Docker environment, this will be a good place to put pandas in the requirements. So every Docker run that's going to install the required libraries that the component needs. Okay, to use the Python template, first the user will have to create a new component, of course. They can clone the repository. This link is essentially linking back into the template that we have over here. Okay, just name it differently. After you clone it, you remove the Git history. Okay, this is the code that you will need to wait. These are the list of Git codes that you will need for removing Git history and then redefining the master branch and stuff like that. The reason why I provide is because there might be new Git users that they are not proficient with the language. So in this case, we are able to help them to move things faster. Okay, second step is you need to set up the CI. The tutorial that we provided in here, they're all on Bitbucket, unfortunately, for the GitHub users or GitLab. As mentioned, the purpose for this was to set up the deployment automation. So every Git version push, it will be automatically push updated code or versions into the developer portal, same as the descriptions and the configuration schema. What you need to do to enable the automation is you need to enable the pipelines. Okay, so once you clone the code and push it into your component in your Bitbucket, you click on pipelines. With the pipeline code that's getting committed into or pushed into your repository already, you will be able to enable it. Okay, so remember, after you clone our template, okay, remember to redefine where it should go and define the master. After that, commit and push the code into your current component or the component that you wish to develop. Okay. After that, click on pipeline. You will need to enable it. Okay. Next thing you need to do is to enable deployments. Okay. These configurations have been configured into the Bitbucket pipelines as well. All you need to do is to commit the file. Third step for the automation is to assign the environmental variables. Okay, so there are in the repository variable is in the repository setting, first of all, and then down here, somewhere down here, there's this repository variables where it define developer portal app. Okay, this is the app ID in your developer portal. Okay, and then there's KBC storage token details. I will go deeper later. There's app image, developer portal vendor ID, password, username. The reason why we're doing this is because we need to grant Bitbucket pipeline access to the developer portal. If we don't, there's no way you can push the data into developer portal. Next slide. Okay, so the definitions on the repository variables. First, the KBC developer portal app, again, is the app ID of the component registered in developer portal. Okay, storage token is used to run KBC automated tests. Okay, the third one is app image, or arbitrary tag name of the Docker image. The fourth one is KBC developer portal vendor, is your vendor ID in your developer portal, which is required. And the fifth one is your developer portal password, and the sixth one is your username. Okay, user has an option to first enter these developer portals account information on the Bitbucket account level or the Bitbucket team level. With that being said, these are the parameters they can configure in there. So KBC developer portal password, username, vendor, ID, app image, storage token. If you predefine these variables inside the account variable, okay, meaning your team, this is KDS team's account variables, we already defined these in there. So every time when we configure or create a new component, all we need to do is to put the KBC developer portal app ID in the repository variables. Okay, it is mandatory for the user to define this in the repository level because this is telling the pipeline where to push the Docker image to. There are three stages in the pipeline. The first one is the default stage. Okay, it executes on push to any branch except the master branch. Okay, it performs a basic build and code quality check. So meaning the flake 8. If the build fails, okay, there is no way the user will be able to merge that branch back into master. So in order to merge it back into master, user will have to make the code work. Second stage, it will basically execute on any push or change to master branch. Okay, it perform on every single default stage has. So whatever it's able to do in the default stage, the master stage will do it too. Plus, it will push the changes into component configuration files into developer portal. Meaning like the configuration schema, short description, long description. The third one is the text commit stage. So execute like this pipeline executes when a tag commit is added. Okay, it performs every other stage can do. So whatever these default stage or master stage can do, the tag commit stage will be able to do it, or they will do it. Okay. Plus, with that, by adding on from it, it will also build and pushes the newest image with tag number into Keboola ECR repository or Docker repository, whatever you defined. So it deploys script. Okay, the deploy script will only execute after all tests and validations are complete. Okay, so it will validate your code if the styling matches, if the code compiles and stuff like that. Then the deploy script will be executed after all these tests are done. Okay, so and another thing is deploy script will be executed in master branch only. So if you branch it off in like a developer branch or a feature branch, the deploy script will not be executed unless you push it back into master with a tag number. Okay, next thing, our template also contains row contain with simple unit testings. So we have Docker Compose over here. So it's commands to run the container and execute code testings. Okay, these configuration can be found in Docker .dockercompose.yml. Okay, if it's required, user can modify the data folder where we mount the configuration and states and the state file and the input output mappings. So here, this is where we mount the data folder. Okay, to run Docker Compose, simply build the Docker image. Okay, here, Docker Compose build. Okay, after that, you specify which services that you want to run. So in this case, you can see dev or test. In this case, in command line, we choose to run the dev one. And then in the Docker Compose code, you'll be able to tell what's being run in that Docker Compose. So here, we're simply building and running the code. But here, in the test service, we're running the code, we're building the code, and we're also building and testing it. So meaning that we're going to run the Flakegate and unit test checks. So if any of these are going to fail, you better fix it before you push it to main branch. While we have a Python template, we also have a Python utility library. It can be found in this link in here. The purpose why we have a Python utility library is because first, we can reduce the code replication. So example will be producing manifests, defining data folder structures. If we have that somewhere, so we don't have to define this or create functions for it every single time when we create a component. Second, pre-configured pipeline and environment variables. The third one, developer can focus on core component logic instead of always spending time on creating these replicated functions. If the user or developer found something that's missing in the library, please feel free to fork and create a pull request with changes they perform to the library. Okay. To use this library, the user will have to pre-install it into an environment or the Docker. Okay. If they have an existing one or an old version, so you can simply upgrade that version with this code here. Okay, in our utility library, there are 3 classes in here, or 3 libraries in here. First, we call it KBC Environment Handler. So what it does is it aids users to set up configuration processing and code validations. And it also has the ability to set up logging environment. C, the third one is it'll be able to help users to create manifest, store manifest, or create state file and a list of dates configurations. The second library we have over here is HTTP client base. So it handles a lot of HTTP requests. Main purpose was to deal with the API requests or post requests. So it covers a basic authentications. And there's also retry strategies within this library that can help us. If something fails, it will just retry it with the parameter you set in there. And also you can define headers and parameters for the HTTP requests. The third one is kbc.results. So what it does is basically helping the user to parse and store the JSON response. There's also the ability to flatten the JSON objects and handle array objects as well. Details will be in the later slides. Let's talk about KBC Environment Handler. So as mentioned, the purpose of this is to handle standard tasks like reading manifests, creating environment, validating the configuration and stuff like that. So in here, the class is called KBC Environment Handler, which is the same name over here, same in the library that we call it. So in this class, so there are mandatory parameters. With this putting in here, it will help the user to validate if the config file has all the mandatory parameters required for this component to run. Okay, data path. So data path is the data folder where we store the configuration, input mapping, output mapping. So during the development stage, you might store the data folder in a different folder or different destination. So this will be an option where you can define it in here. If it's not specified, the default data folder will be in the same directory under data. So I'm going to list out a few useful functions in this class. Okay, so one of them is validate config. So with this being called, in our template, there's also a function called validate config. So once we put the mandatory parameters in here, it will validate between the config JSON and the array of mandatory parameters. If it's missing, then it will fail. The component run will fail. Next function is the image parameters. Okay, so same thing as configuration JSON. It will just validate the mandatory parameters for the image parameters. The third function is setting default logger. Okay, so you can define the logging level in here. So if you want it to be debugged, then this is where you're going to define it. So get state file. If the user hopes to get the state file from the input mapping, this will be a good function for you. Okay, so it will return a dictionary file, okay, with the properties in there. Write state file. After the component run, if you wish to store the state file, this function will be able to help you. Create slice table. Okay, what it does is basically prepares a slice tables from all files in data path. Okay, out table in this folder, like the tables that are located in this folder. And what it does, it will remove all the headers and create a manifest with provided parameters. Okay, what this function accepts in the argument is folder name, okay, where the folder is located for those slice files, and what kind of primary keys you wish this table is going to have. And there is also delimiter, enclosure, destination bucket. You can all define these in here. There's also a function called create manifest. Okay, so it will write manifest files for the result provided by KBC result. Is also a library that we have that we're going to talk about later on. Another function is get and remove headers in all files. Okay, so with the file specified in here, all the headers will be removed. Okay, and there's also an option that this function will return the header as a list. Okay, if there's one file in the list of files that you provided in here that has misaligned a header, meaning that one file might be missing a column compared to the rest of them, then this function will fail. Get past date. So there are a lot of cases that in Keboola we orchestrate, meaning that we automate the component run to be on daily purposes or weekly or monthly purposes. So with this get past date, we're able to just put today as a date parameter, then it will run automatically every single day to pick up the newest date or to pick up today's date. Split dates to chunk. Okay, so we have an example over here, okay, where we define the start date, end date, interval, and then the format of the output. So list here, this is the parameters we put, and then with that being run, this will be the output. Okay. HTTP client base. The purpose for this is to handle the requests for REST API, including post requests or get requests. So when we call this class, we can define the base URL. We can also specify the retries that we want to allow. Backoff factor is basically the backoff factor between attempts when it fails. And for status force list is where you put the status code that you wish the component to force to retry. Default HTTP header is to be sent for each request. Usually is like application / JSON, the content type essentially. Authentication object is going to be attached in here. Default parameters, usually let's say start date, end date. Okay, so I list two functions in here. One is called get raw. So it handles the get requests with the arguments and keyword arguments and process the results. So this will return you a JSON data result, same as the post. All right, moving on to the KBC result library. Okay, the purpose of this is to convert and parse the JSON to a desired output that we want. Okay, by calling this class, we'll define the file name, the full path, and also the table definition, which is the class down here. Okay, so the desired table name, column names, primary keys, and the destinations. So to use these two classes, we combine them into one and use it in this result writer. Okay, so this is where we define the desired directory to output the results, the table definitions, which we define in with this class, fixed headers, whether to use the header specified in the table definition, okay, or the file itself. So next thing, flattened objects. So meaning that if the JSON is really nested, meaning that they have multiple levels of properties in there. So with this enabled, the class or app function somewhere in the class will automatically flatten out the JSON for you, so you don't have to parse it. And then exclude fields is where you can put like the list of column names or the list of columns that you wish to be excluded from the output or from parsing. So user value columns is basically list of columns to be added into the JSON root object. And buffer size, optional size of buffer use with the writer object. So after we configure all the table definitions, all the column names, if you want to parse them and stuff like that, then it's time to write it. With this function over here, we will be able to define, okay, this is the data of the JSON object that you parsed or the component parsed, okay? So this data file or data, JSON data will be given this file name that we configured in here, okay? User values, object from arrays, this is yes or no, is to tell the application whether or not if there's an array in the JSON property, whether you put it as a new table or not. Write header, specifying whether to write the header or not. Usually we only need this when we're creating slice files. Of course, for normal data output, we will leave this true. If not, then when you create slice files, you put this as false. And these are the resources that we have. We talk. I mean, these are the resources we went over throughout this presentations. So there is this component template. These are clickable links. And this is the Python utility library that I just mentioned with list of functions that the user can use. Keboola component documentations. This is the standard component documentation we have for Keboola, meaning that there will be a lot of details regarding component creation in here. And the last but not least, the Keboola developer portal. Thank you everyone for joining this component creation presentation. So if you have any questions, feel free to reach out, and thank you.